Assalamu alaikum. First of all, I'm honored to be a speaker here and also to present this on behalf of the team of this project. The outline of my presentation is I'm going to give you background about the Arabian Gulf and why you will know later. Then the project review of using remote sensing for oil detection, for oil spill detection and monitoring. And then I'll shed some light about the technologies that we have used in this project. And then I'll conclude with the recommendations. Now the Arabian Gulf, which is all the GCC countries are having access to, is a length of almost 1,000 kilometers with an area of 250,000 kilometers square. However, the depth average is 50 meters, so it's not that deep. And the maximum, as you can see from this bathymetry map, is 95 meters, only in the small areas there. It's also, the GCC countries are relying on desalination plants for the water resources, the fresh water that we're actually using. And as you can see from the slides, we have 199 desalination plants all over the Gulf. Saudi Arabia has 97. However, there is also increasing of 38 in the near future, where Saudi Arabia will have 11 of those. And as you can see, the Gulf is actually the main source of desalination plant for the Gulf countries. It's actually the largest in the world, as you can see from this slide. Again, the Gulf is rich in environmental and marine life. It has dolphin, it has even, the place of an endangered species, which is the hawksbill, sea turtle. The dugongs actually is, we have the second largest dugong population in the world after Australia. Coral and flamingo is another important life that the Gulf is housing. In 200,000, the US Energy Information saying that the Gulf is producing 20 to 25 of the world crude. And if you look into the transportation of that crude, 30 to 40% of the world seaborne oil shipment is done through the Gulf, this small area. An average of 14 tankers carrying 17 million barrels per day. Now all of that will show that if an oil spill happened, it's going to have really devastating effects of the Gulf. And as you can see, it's going to endanger the fish industry, the water desalination plant, and all of that. So, and also the recovery process for that, it will be a very extensive operation, time-consuming and very costly. So, when we have, getting all of those information, we would like to see a technology that actually gives us a warning of how an oil spill is happening, so we can contain it as the first early stages. So we had a project where it's the objective of its early detection and monitoring and verification of the oil spill. The project team is Dr. Abdullah Majid Al-Khali, me and my colleague Mahdi Abu Al-Harith. And the area was selected is Safaniya, and which is a very heavy oil industry crude producing area. The service area, as you can see, it's 1,400 kilometers square. And then the period we took was from October 27 to 2030 to November. But it's not showing here. Oh, it's November 27. No. Where is the next one? Okay. Well, I looked actually the technologies that we have, and as everybody knows, the remote sensing has passive and active. The passive is actually the visible range of satellites, which is the Landsat, Iconos, GEOI, etc. And then there's the microwave one, which is actually the active one, which is the radar, and they have radar sat 2, TerraSAR, Cosmos Sky mode. And as you can see from the table, when we looked into that and we analyzed it, we found that the most suitable one is the Cosmo, because it gives us actually 2 images per day. So that gives us an early, at least 12 hours notice if there is any oil spill happening to the area there. Now, once we have analyzed that, we went further and we checked the polarization, and we found out, sorry, this is, can I go back now? I'm doing it, but it is not, this one, okay. No, it's not working. Seems to be the link is not working. However, I should have a slide here showing that the type of polarization, which is radar, comes with 4 probably polarization, if you know. It's like HH, VV, VH, and HV. And we found that the VV polarization actually is the most suitable one in terms of defining oil spill. The swath of the sky mode is a 100 kilometer by 100 kilometer for the wide region or the ScanSAR mode that we have selected. Resolution is 330 meter. And then also the band software, the band that we are using is the X band, because it's a very short wave, so it will not penetrate through the sea surface. It will reflect, the sea surface itself. And then we have done some interpretation of the result, because it's not an easy to get an image and you immediately define this as an oil spill, because it can be actually affected by natural slick, internal wave, and wind less than or greater than 3 meter and 10 meter. So because if it's more or less, it can have a bad interpretation or wrong interpretation. And then we define the oil spill to high or low based on some parameters, based on the shape, based on the edge, based on the contrast of the image itself, if it is dark or a little bit of reddish or yellow, not yellow, sorry, white or gray, and then the surrounding. So if you have like a platform nearby, so at least you can make sure that this isn't a spill, or if there's nothing, no surrounding or no platform there, then maybe it's like a normal slick. So here's the sample of the radar images, and alhamdulillah there was no spill at that time. But here is some examples of spills that happened in Italy. Like you can see, that shape is like an oil slick. And here is another example of also an oil spill, which is those dark spots there. This is a third one, also happened in Italy. Then we went into the passive, which is we have used iconos to see, if we can actually, use it to determine oil spill. So these are the characteristics of the iconos. When we had the picture, and we just do the RGP, processing, we could not see anything. But when we did with the enhance the contrast of the water level, as you can see, we can see there was an oil. So now we have actually both resources, but both has to be processed, either the radar or the visible. And then we think further, and we say if we link it to actually the marine AI system, we can even, now track the ships that actually dump oil in the Gulf. So here is another source. If there's people, there are some kinds of ships that when they comes in the Gulf, they empty their tanks, to clean it. So we can actually trace who's actually the ships that doing those dumps to help us, catch them, or at least, warn them to not to do contamination of the Gulf or water there. So in the conclusion, SARC, which is the radar technology, can detect and track not only the heavy oil spill, but also light oil spill. Has an advantage over passive, which is the GUI and iconos, because it can be used anytime. As you know, the GUI or those, we call it passive, it's only, they have to be in the morning where there's a sun resource or an energy resource. VV polarization is better in timing of the radar to detect, oil spill. Also passive, we have found that it can do oil spill detection. However, we have to do some processing there. I think the radar is a cost-effective for large area because, as you can see, for 10,000 kilometers, for one scene, you can, check that area if there is an oil spill or not. However, it requires interpretation and verification, and can be used to track even vessel and tank numbers if we are being linked to the EIS system. And just by that, I conclude my presentation. And these are some of the resources that we are used. And thank you.
Thank you. Thank you, Ron.